Thank you very much for this invitation. It's my pleasure to be here today. I will be speaking today about the search for life in the universe and inhabiting the uncertainty in that regard. So the question of whether we're alone in the universe is one that humanity has contemplated for millennia. But if you'd asked just 10 years ago whether Earth-sized planets existed in the universe, no one could tell you the answer. Even though there were hopes and educated guesses, no human, alive or dead, knew for sure. But today, those dreams of potentially habitable worlds beyond our own, which were once the purview only of science fiction, are part of our science reality. This recent revolution is due largely to NASA's Kepler mission, a space telescope that was dedicated to finding planets around other stars, and specifically to figuring out whether planets the size of Earth are common or rare. Now, I became part of the Kepler mission science team just before its launch in 2009, and at that point, more than 20 years of hard searching for planets had yielded only around 400 planets, most of which were more like the large gaseous planets in our solar system, Jupiter and Saturn, for example, than anything we'd expect to find life on. Now, in the 10 years since its launch, Kepler discovered over 3,000 planets, and many of these planets are small, rocky worlds. More importantly, the census of planets that we have discovered tells us that there must be billions of planets in our galaxy alone. Now, not only do planets abound, but our discoveries reveal that small planets, the planets that are perhaps similar to Earth, Venus, or Mars in our solar system, are the most common kind of world. But even as we find more and more of these planets beyond our solar system, there are really a lot of questions that remain. They may be close to our own planet in size, but what are they really like? Do they have atmospheres, and what are those atmospheres made up of? Do they have water? Do they have oceans? And when we find planets that are somewhat larger than Earth but smaller than Neptune, should we consider these potentially habitable environments as well? And what about moons? If they orbit stars that are very different than our sun, what does that mean for their habitability? And perhaps most tantalizing of all, is there life on any of these worlds? And if so, how will we detect it? Now, answering these questions is very challenging because while we as humans love to imagine other planets and we create artistic expressions of what they might look like the images that I'm showing here, often we know few details about these worlds and are really uncertain as to what they're really like. Now, this uncertainty comes from the methods that we use to find these planets to begin with. And the problem really is that stars outshine their planets stars outshine the planets that orbit them, often by a factor of 1,000,000 to 1,000,000,000 times brighter. So astronomers must be very clever to detect that the planet is there at all. Now, most recent planetary discoveries have been made using the transit method, where we search for the shadow of a planet passing in front of its parent star, blocking just a little bit of the starlight and making it appear dimmer for a few hours. Now, we can't really see the shadow of the planet against the star like I'm showing you in these movies. So what we do instead is we measure the brightness of the star over time and detect the planet's shadow indirectly. Now, using this method allows us to learn the planet's size, how much light it blocks, and timing how long it takes for these planets to orbit and the transit to happen again and again tells us how far away the planet is from its star, and in turn, how much light it receives. So in order to know whether these planets are suitable for life and to find worlds that might be suitable for life as we know it, we kind of think about the star like a campfire. We want to find planets that are just the right distance from the star, so they're not too close and thus too hot, and not too far away from their star where they might be too cold. So if we have planets that receive about the same amount of light from their star that our Earth receives from the sun, we say that they're in the habitable zone. But does this truly mean that they're habitable? We don't really know. Before Kepler, finding these potentially habitable Earth-sized planets was a mystery, but now it's really an industry. And I'm glad to say that the present era of planet hunting is really bright. And in part, that's because while Kepler has ended its mission, for the past few years now, the Transiting Exoplanet Survey Satellite, which is also known as TESS for short, has followed Kepler's footsteps to find planets around bright stars, the planetary systems that might be some of our nearest neighbors. So just last year, my student, Emily Gilbert, who is a graduate student at the University of Chicago, led the research effort to find TESS's first Earth-sized planet in the habitable zone. This is a a system known as TOI 700, where TOI just stands for TESS Object of Interest. And this planetary system is very interesting indeed. Unfortunately, planets around other stars are so far away that we can't just get in a ship and go there like they can on Star Trek. So instead, we use telescopes, not just missions like TESS, but also ground-based telescopes such as Magellan at Las Campanas Observatory. We can try to understand the composition of some of these planets by measuring their mass and providing an estimate then of their density. And one of the most exciting things coming along now is a new mission called JWST. And JWST is a space telescope that will be targeting these planetary systems discovered by TESS. And now JWST, whose mirror you see down here on the right in the lab at NASA Goddard Space Flight Center, will be really revolutionary because it will measure the starlight as it bounces or filters through the atmosphere of these distant worlds. Because the chemical makeup of gases in their atmospheres absorb different, very specific energies of light, this technique is like taking a fingerprint of the chemistry of another world and allows us to figure out what their atmospheres might be made up of. The chemical fingerprints measured by JWST will make it possible to search for what we call biosignatures, the combination of atmospheric makeup and conditions of temperature that are key to finding out whether these worlds are not just habitable, but inhabited. Now, the tricky part is that no one atom or molecule can tell us just by its presence whether life is there or not. If we look at our own Earth, for example, we humans often think about oxygen, which we need to breathe, and carbon dioxide, which we exhale, and which is produced not only by our exhalations, but on a very large scale by industry. And we add to that there's mostly nitrogen in the atmosphere and then lots of other trace species of gas as well. So oxygen alone can't tell us whether there's life on Earth, but rather the very particular balance of gases in our atmosphere is what would hint to an alien astronomer looking at our planet that we're here. So looking for biosignatures can tell us if life is on a planet, even if we can't travel there and see it for ourselves. But the drawback is that this method doesn't tell us what kind of life is on that planet. After all, here on Earth, the biggest changes to our atmosphere in the past was the rise of oxygen billions of years ago. And that was created by an ancient form of life, which is still around today, called cyanobacteria. These bacteria build these rocky-looking structures that you can see on beaches around the world called stromatolites, including here in Chile in Stromatolites Park. But unfortunately, they are a little bit hard for humans to talk to. So from this point of view, one hopes that in the distant future, aliens will not look back at the Earth and see a world that is only carbon dioxide, but instead we'll see a nice habitable planet like the one that we have today. So the next question, if we can't talk to these rocky structures or bacteria, is how can we find life that is like us, or at least life that we can communicate with? The search for extraterrestrial intelligence, or SETI, S-E-T-I, refers to the decades-long effort to find signals from technologically advanced life, the kind of life that, like humans, might build communications that are detectable across interstellar space, whether intentionally or by accident. Now, traditionally, SETI searches have operated by searching for radio emission, mostly because humans use radio waves to communicate over long distances, so we figure other life out there might do that too. Now, today, initiatives like Breakthrough Listen continue these searches, but people, including myself, also search for unusual signals in visible light as well, not just radio waves. And this is the kind of light that might be detectable by a mission like Kepler. Now, historically, the downside of SETI searches has been trying to guess what kind of signals another truly alien intelligence might send. And after all, we have enough trouble trying to communicate with other intelligent species on Earth. Whales, for example, are very smart, but we still can't really talk to them. And that doesn't stop us from trying. Of course, there are many scientists that investigate cetacean communication as well, in part people who are motivated by SETI, or the search for extraterrestrial intelligence. But here, too, we have new opportunities. And one of the most exciting things happening in astronomy right now, I think, is that we gather more data than ever before. So much so that we can use advanced computing algorithms, including something called machine learning, to find new phenomena. Machine learning algorithms are a part of your daily life, even if you are not aware of them, because companies use these algorithms to study all kinds of data made by humans, including things like how often you shop, what you search for, and what you buy, all in the hopes of enticing you to buy more things. But we can also use these in astronomy. And in the case of my student, Daniel Giles, Dan just completed his PhD at the Illinois Institute of Technology, and his work was using machine learning to develop automated methods to search big data for unique or unusual signals. So this kind of research approach flips the older approach on its head, where instead of trying to figure out what aliens might send you and then look for that in your data, you just look for things that don't resemble anything that you've seen before. Now, that doesn't mean that anything that is unusual is going to be aliens. In fact, it's unfortunately probably not. But you still have a chance of finding things that are very unusual and that you weren't inspecting, and you still have to investigate anything that you find. But this is a complementary approach enabled by advanced computing and the growth of data in astronomy that still might result in finding something completely new. And in fact, the possibility of finding what we are not looking for, new phenomena, whether it's some exciting new astrophysics or potentially life beyond Earth, is one of the things that I am most excited about from the Vera Rubin Observatory, which is nearing completion on Cerro Pachón right now. Now, at the same time as we gaze out to these distant worlds to study them, we're also learning more than ever before about planets within our own solar system, including our neighbors Venus and Mars. In just under a month, in fact, new missions to Mars will begin arriving, including NASA's Mars Perseverance rover. Now, much of what we have learned about the possibility that Mars in particular had life in the past, or even has life under its surface today, we've actually learned from places on our own planet. And in particular, high-altitude lakes in the Atacama are environments on Earth today that might resemble what the environment was like on Mars billions of years in the past. So in this way, our study of our own planet deepens our understanding of space and vice versa. At the same time, the planets and moons of our solar system also keep us very humble. As amazing as our ability to detect biosignatures on exoplanets might be, we can look to worlds like Jupiter's moon, Europa, which doesn't have any atmosphere at all. If Europa was a distant planet, we might not be able to tell whether it could harbor life or not. But because Europa is here in the solar system and we can study it so closely, we know that it has an ocean under this icy crust that you see in this image. Does the ocean have life in it? Well, that we don't know. But with each new discovery always comes uncertainty, and with uncertainty comes possibility. So as we gaze out into the universe at this moment in human history, we're faced with not only a chance to know the context of our own Earth, but to also the very real possibility that we will discover life amongst the stars. And as a space-faring species that has both the mental and technological capacity to contemplate our place in space, the worlds of our own solar system truly become our Rosetta Stone, each with their own story to tell about the rise and fall of life in the universe. Many people, including smart and/or famous people like Stephen Hawking, have expressed fear at what it might be like to finally come in contact with alien life, that not knowing their motivations, they might be a danger to humans. Now, that's possible, but honestly, I think it more reflects the fears that descendants of European colonizers have about being colonized themselves. And after all, not knowing the motivations of another intelligence could just as easily mean that we would have much to learn from them, that perhaps they've solved some of the greatest challenges we face to human health, the sustainability of our climate, and ensuring flourishing and dignity for all life on Earth. As my colleague Jason Wright very poetically puts it, planets around other stars have a special hold on the human imagination, because more than anything else one might study as an astronomer, they are truly places, We can imagine ourselves there, and via our technology, we can truly know our place in the universe. And in part because of their unique hold on the minds of people everywhere, these planets are not abstract. They're gateways into a fascination with science and technology, and to the incredible and deceptively simple sounding fact that the universe can be known just as we know ourselves. The quest for planets around other stars may have once been science fiction, but even as it is now science, the questions that it asks are fundamentally human. Thank you.